Hello and welcome to this topic. Today I want us to discuss the gradient and the equation of a straight line. Gradient and equation of a straight line. A straight line, as we know, is a line joining any 2 points. For example, I've written here is a line joining any 2 points. Ideally, a straight line joins or is a series of many points. But in this lesson, I want us to say that a straight line is a line joining any 2 points. So I have considered only the endpoints here, but we know that this straight line, for example, here passes through a series of many other points in between. I've given you examples A, B, C, D, and E, F. Let's look at my graph here. A, B is a line joining point A and point B. So these over here I've written are called coordinates. Coordinates 1, 5, 1 representing displacement from the x-axis, so 1 point, and then 5 representing displacement from the y-axis. So the coordinates of B is 5, 1 also, 5 on the x-axis and 1 on the y-axis. So we have these other lines, EF, a line joining point E and F is called line EF or FE, whichever way you want to call it. We have CD, line joining through the points C and D, or D and C, makes another straight line. So these I've written in bracket are called coordinates. Coordinates is a position of a point. First, how far is it from the x-axis? Then next, how far is it from the y-axis? Okay, let's now begin. Straight lines are very interesting. They have several properties. Let me take you through the following. 1. A straight line must have a gradient. A gradient is a slope. A straight line has an equation. A straight line has an x-intercept. A straight line has a y-intercept. And also, we shall look at the angle made between that line and the x-axis. The angle can be acute or obtuse. We shall explore later. In this lesson today, I want us to concentrate on number 1, gradient. Then number 2 up to 5 will be discussed in our subsequent videos. Welcome. Let's begin on gradient. Grab your pen and a piece of paper and let us learn this topic better. Gradient of a line. Gradient of a straight line. Let's begin by saying that the gradient of a straight line is given by change in y over change in x. We shall understand shortly why I write that. Change in y as the numerator and change in x as the denominator. When we are given 2 points, let's say x1, y1, and another point x2, y2. So x1, y1 might represent 1, 5, and x2, y2 represents 5, 1 in this graph. So the gradient, when we are given these 2 general points, we shall write gradient. I shall use grad here to represent gradient. Shall be given as change in y first. So change in y, you can say y1 minus y2 in general, y1 minus y2. That is the change in y, divided by change in x. Let's remember we began with y1 minus y2. Then for the denominator, we must also begin with x1 minus x2. So we shall now look at examples from this graph. Let's calculate the gradient of these 3 lines. These 3 lines, I have drawn them for you. So we have the coordinates. We have a general point x1, y1, x2, y2. But in these examples over here, we shall know our x1, x2, what values they are, and calculate the gradient of those lines. Let's begin with line AB. Let's write line AB. Let's look at line AB. Line AB, we said, is a line joining point A and point B. So what is my x1, y1? We can take that to be point A. So point A is given as 1, 5. And then we have our point B is given as 5, 1. All right, so what is the gradient of line AB? What is the gradient of line AB? We said now when we're given these 2 points, first let's do change in y. We can now take our y1 to be 5, y2 to be 1. Therefore, our gradient shall be equal to y1 5 minus 1. Remember, we only pick the y coordinates 5, 1. And then on the denominator, change in x. Change in x is x1 minus x2. What is my x1? 1. Minus, what is my x2? The x coordinate of the second point, 5. So what does that give us? So 5 minus 1 on the numerator is 4, divided by 1 minus 5 on the denominator is negative 4. That simplifies to by 4, 1 by 4, 1, and the gradient remains what? Negative 1. We can now say that the gradient of line AB is negative 1. The gradient of line AB is negative 1. Alright, I hope we are together up to that point. Can we do together the gradient of the second line? Let's pick line BC. Line BC. Line CD. Let's look at line CD. So let's consider line CD. Calculate that with me. What are the coordinates of C? 0, 3. What are the coordinates of D? Negative 5, 0. So the points, I'm picking it from our graph. Point C is 0, 3. Point D is negative 5, 0. Therefore, the gradient of the line CD is change in y over change in x. So we can begin by using now the first y as 3 minus the second y 0 over the first x 0 minus the second x negative 5. So this simplifies to 3 minus 0, 3 over 0 minus 5, 0 minus 5, that turns to a positive 5. Therefore, the gradient of line CD is 3 over 5. Can you find the gradient of EF? Gradient of EF. Let's consider line EF. Line EF, what are the coordinates of point E? Point E is 1, negative 4. What are the coordinates of point F? Point F is 4, negative 2. And what is the gradient? What is the gradient? Attempt that question. Calculate the value of the gradient of line EF and leave your answer on the comment section. Thank you for watching, and kindly subscribe to this channel. Share this with your learned friends, and kindly watch the next video when we discuss the equation of the straight line, x-intercept, y-intercept, and the angle it makes with the x-axis. Thank you very much, and bye-bye.